Oh, this section that I'm going to cover on solving systems with Laplace transforms will definitely be on your final. So put a big star next to this section because you'll definitely need to know how to perform this for your final. This will certainly be at least one of the 6 problems that will appear on your final this Saturday. Okay? So the question will be stated this way. Solve the following system Okay, solve the following system. Okay, using Laplace transforms. Transforms. Okay, so it's a simple problem statement, and I'll show you the system of equations you'll be doing. Likely, it'll have exactly the same form, just different numbers. It'll be x prime 1 equals 3x1 minus 3x2 plus 2. Okay, and then x prime 2 equals minus 6x1, okay, minus t. And the initial condition for the first equation will be x1 of 0 equals 1. And the second equation will be x2 of 0 equals negative 1. All right. So first thing I want you guys to notice is that the system is not given in matrix form. Okay. And this is because the system won't be solved in matrix form. That's the first thing to notice about Laplace transform solutions. Also note that the system is non-homogeneous. Okay. There's no zeros. So we just start just as we did when we used Laplace transforms to solve a single set of differential equations. We simply take the transform of both differential equations. So for the first one, this will be s times x1 of s. So you have to recall back when we did Laplace transforms why we do it this way, minus x1 of 0. But also a disclaimer for you guys is that your problem on your final will be solved in exactly the same way as well. Just different numbers, different values, different integrals, and so on. So you can follow this pattern if you wish. But if you go back to Laplace transforms during that lecture, I show you why we transform it this way for the derivatives and the non-derivatives. So the left-hand side becomes, for the first equation, s times x1 of s minus x1 of 0. And this becomes 3 times x1 of s, okay, minus 3x2, it's a 2, of s, okay, plus, and then the Laplace transform of a constant, right, is just 1 over s, and you just pull out the constant and then multiply it back, so you get 2 over s, okay. So be sure you have a table of Laplace transforms with you when you guys solve these, and also I will provide one to you so you can make the proper transformations. This is where students usually miss some of their problems because they picked the wrong transformation or they didn't write it down correctly. And if it's written down incorrectly at the very beginning, then the rest of it will kind of fall to pieces. So just make sure you know how to do this very, very carefully. That doesn't mean I'm going to mark you off completely. I mean, if you do a little mistake with your Laplace transform, but you carry that consistently through your solution, I do give you points for that. But I want you guys just to be extra, extra careful when you do a Laplace transform. Make sure you use that table very carefully. Okay. So that's the first equation after we apply a Laplace transform. The second equation after transforming will be s x2 of s, okay, minus x2 of 0, all right, and this is going to equal negative 6 times x1 of s, all right, and then to transform a variable t, there's no constant. In this case, the constant is actually negative 1, so you don't have to worry about multiplying a constant in, but you can just look at the table. The Laplace transform for t is just 1 over s squared. Okay. And now all we have to do is just plug in the initial condition and simplify things a little bit. So now we plug in these initial conditions and we can simplify things a little bit for these two equations. And what we end up with on the first equation is s minus 3 times x1 of s, okay, plus 3 times x2 of s. All right, now those are on one side, and the right-hand side is going to look like 2 over s plus 1, and that's going to simplify to be 2 plus s all divided by s. Okay, and the second equation is going to be 6 times x1 of s, all right, plus s times x2 of s, all right, and this is going to equal negative 1 over s squared, all right, minus 1, and this is going to equal negative, and the fraction is going to say s squared plus 1 all divided by s squared. All right, so those are the first few steps you would do in solving this type of problem on your final. So in the next video, I'll show you guys how to solve for x1, then using partial fractions, and then taking inverse solutions to get the actual solution for the differential equation. And there's a few additional steps we have to do with the second solution as well. There's a first solution we need to solve for and a second solution. Put them all together, solve the IVP, and then we're done. And stay tuned. The next video will go into that in much more detail.